Hey friends, we are going to continue 1.7 notes. I'm not sure if yours are this microscopic or not, but yeah, we have teeny tiny examples today. We also have this really giant empty space where they don't have any words. So let's put some words there. What we're focusing on today, and just maybe put it up here day 2 to help yourself out when you're matching up with like your homework page. We're going to talk a little bit more in depth about slant asymptotes. Also, my laundry is going, so that's going to be making some weird noises in the background. And I have dogs who always make weird noises, so let's see how this goes. Okay, we talked about this one briefly in day 1, and that's basically if the degree of the top is 1 greater than the degree of the bottom. Now we're going to pretend I use numerator and denominator because we're trying to be fancy, but I don't want to write that. So I'm writing degree of top is 1 greater than degree of the bottom. So the top is bigger than the bottom. That guarantees you will not have a horizontal asymptote, but you will have a slant asymptote if the top is 1 degree higher. Okay. And you're going to find the slope, essentially, of that asymptote by looking at the ratio of the leading terms. So you know that when they use the phrase parallel, which is going to happen, they'll say it's parallel to. Essentially what that is saying is it means same slope. So it's going to say it has the same slope as the ratio of leading terms. Well, that means, it's going to say it's parallel to, but that's going to mean that you've got the same slope. I'm not having a rough start, so let's dial in. I'm looking at the complete notes and what they have written in this box, and it's really long and confusing, and I don't want to write it that way. So I'm struggling, clearly, to write it in a little bit more straightforward terms. So the key is to know that you will have a slant asymptote when the top degree is 1 greater than the bottom, and also you'll find the slope of it, or it's going to be parallel to the ratio of the leading terms. So if you end up with y equals a over b, you will have one x left. If you think of it in terms of canceling, because the top is 1 higher, this is going to be the slope of your slant asymptote. That makes it super complicated. So let's look at some examples. It says, which of the following really super teeny tiny rational functions has a slant asymptote parallel to the line 1/2 x? So what we need is our ratio of our coefficients to be 1/2. So let's look at these ridiculously small things. So here you have a top and a bottom that are the same degree. See how they're both 2s? So that doesn't even have a slant asymptote. That would have a horizontal asymptote. And that would be located at 1/2, y equals 1/2. Because I would still use the coefficients, but since the top and bottom are equal to one another, then I just cancel out the x squareds, and what I'm left with is the value of my horizontal asymptote. In this next one, the top is a 2 and the bottom is a power of 3, so the top is less than the bottom. And if you recall from day 1, which is something you need to be able to recall, this one's going to have a horizontal asymptote located at y equals 0. That's because the bottom of the fraction is going to be getting bigger faster. And if you think of how fractions work, like 1/2, 1/3, 1/4, 1/5, 1/6, 1/20th, 1/40th, 1/100th, as the number on the bottom gets bigger faster, your fraction value goes towards 0. It gets really small. Okay, so here we finally have our situation. The top is a power of 2, the bottom is a power of 1. So we are in the situation where the top is not only greater than the bottom, indicating there is no horizontal asymptote, but our top is greater than the bottom by 1 power. So here I have 1x squared, if I only look at the leading terms, over 2x. And you can more or less think of it as saying, hey, this x on the bottom cancels 1 on the top. So I'm left with y equals 1/2 x. And this is indicating the slope of my slant asymptote because it's saying it would be parallel to a half. So this is going to be one of our options because that's what we're trying to do. In the last or the fourth example, we do have a situation where the top is greater than the bottom, but it's not specifically a slant asymptote because this one, the top is I wrote 2 because I was saying 2, is 2 degrees higher than the bottom. So in this situation, if you simplified this, these 2 would cancel 2 of these, and you'd end up with 1x squared over 2. That's not going to be a line. Like, that's not going to be specifically called a slant asymptote. So here, in our last example, if you drew this slant asymptote of 1/2 x, you'd be going up 1 over 2, up 1 over 2. And so the ends of your graph would approach that line. But in this problem, you guys know that y equals 1/2 x squared is a parabola opening up. And so what would happen here is the ends of your graph would approach this, but it's not technically a slant asymptote because slant asymptote indicates it will be a line. So this one has a 1/2 in front of it, but the only one that would actually be a slant asymptote that would have the proper slope is going to be 3 only. So of our almost invisible examples, only 3 is doing what they are describing. Okay, now it asks us to determine if the following, by the way, I think I haven't been great about this. This is our concept for today. And then the rest of what we're doing down to the bottom of the page is just gonna be examples. But the concept's really important. And you guys learned from the first test that concept is a big part of it, more than calculation sometimes. So you wanna make sure you're comprehending that. Okay. We are determining if the following rational functions have horizontal asymptotes from day 1, a slant asymptote, or neither. If it's a horizontal asymptote, we're going to write the equation of it. So we have to write y equals, you don't just say horizontal asymptote at something number. You write the equation. And if it has a slant asymptote, write the equation of the parallel line. So, okay, let's just do examples and then that will become crystal clear more so than the instructions. So in each of these cases, we're still comparing the top degree, which is 1, to the bottom degree, which is 1. So in this scenario, the top and the bottom have the same power or degree. I'm only concerned about these leading terms. And so when that's true, I have a horizontal asymptote and it's located at the coefficients, which would be 5 over 1, but I would just write it as y equals 5. In option B, or example B, I'm again looking at these first ones. The top is not only greater than the bottom, so that indicates there's no horizontal asymptote, but it's bigger than the bottom by 1 power, because this is an x to the second power, and this is 1x to the first power. So this one is going to be a slant asymptote. And if you reduce this by canceling this out in one of these, you end up with y equals 1 over 1x, or just y equals x, keeping in mind that that has a slope of 1. And so the slant asymptote will be parallel to y equals 1x. And that's the equation that they're looking for you to write. Okay, here I'm going to look at just my leading terms. And so I have a 4x to the fourth and an x to the second. This is, again, the top having a greater power than the bottom because this has a power of 4 and this has a power of 2. But this is, so that indicates that there's no horizontal asymptote. But because this 4 is not just one bigger than the bottom, there's also no specific slant asymptote that's linear. And so this is going to be neither. What would the graph do? Basically, if I reduce this, I would end up these two x's canceling two of these, and I would end up with the ends of my graph following 4x squared, but that is not a line. It's not a horizontal asymptote. It's not a slant asymptote. And so the proper answer here is that it has neither, and since it has neither, I'm certainly not giving an equation. All right, taking a look here. If you just focus on this the first term on the top and the first term on the bottom, you can see that the top is again greater than the bottom because this has a power of 3 and this is only a power of 2, and it's by 1. So that is going to tell you up here, you know that there's no horizontal asymptote, but because it's bigger by 1, that indicates that there is a slant asymptote. And if we canceled two of these, we'd be left with just one on top. These would reduce. And at this level of math, you certainly have to do that. And our line would be y equals negative 3/2 x. And that's going to be the line that our slant asymptote is going to be parallel to. So if you think about that, you have a slant asymptote that has a negative slope like that. It's going to be coming down from left to right. So when we think about what the right and left ends of our graphs are going to do, they're going to follow that slant asymptote. So like up here in B, where we had a slant asymptote of y equals x, that line goes up from left to right. So the graph will follow that as well. And our right end will go up towards positive infinity, and the left end of our graph will follow downward towards negative infinity. So you want to kind of think about that. And this one had horizontal asymptotes, so that's not the issue. Okay, let's take a look at E and F. If you take a look at this, the top is greater than the bottom, so that guarantees there's no horizontal asymptote. It is greater than the bottom by 1, so that's going to mean that you do have a slant asymptote. And if you think about just those first two terms, this x cancels one of these. My slant asymptote is going to be parallel to the line y equals 2/5 x. So this is what it's parallel to, meaning it's going to follow that up 2 over 1, up 2 over 1. And again, if I drew that, that is a positive sloping line. So the right end of my function will go towards infinity, and the left end of my function will go towards negative infinity. Because no matter what your graph is doing, the ends will approach the horizontal asymptote if you have one, or in this case, they will approach the slant asymptote if you have one. So once you know you have a slant asymptote, your right and left ends are going to be going towards positive or negative infinity, not towards a number like they do with a horizontal asymptote. All right, last one. Hopefully by now you're kind of starting to catch on. This has a power of 1 and the bottom has a power of 3. So the top power is less than the bottom power. That actually is one of the times where we know we have a horizontal asymptote. And since the bottom is getting bigger faster, it will be located at y equals 0. So keep in mind, this is getting ahead of ourselves a little bit, but who doesn't love that? If I was asked to write the limit of this function as x approaches, and in this problem, it's going to be either positive or negative infinity, meaning right or left, the answer is going to be 0, because if you have a horizontal asymptote, the ends of the graph will approach that. Last thing, if I had something like up here in D, where I have a negative 3/2 x as the slant asymptote, then, or at least the slope of my slant asymptote, I know my slant asymptote looks like this. So here, the limit as x, okay, wait, now I messed up. You guys, how do I make this go away? There we go. Wow, that's giant. Okay, technical difficulties. So what I was saying is down here, the limit of this function, which was k of x, And I have to separate these. As x approaches negative infinity is indicating the left, and since the left end of my slant asymptote is going up, so would the left end of my function. And similarly, if I have to write a limit statement about the right end, meaning x approaching positive infinity, the right end of my graph, whatever it's doing, is going to follow that slant asymptote, which is going downward. So this one's going to be negative infinity. That's not going to be on your homework for today, but it is going to be like what we need to know. So no harm in tacking that on there. Sorry for the technical difficulties and the really teeny tiny little examples. I'm hoping yours are bigger. Hope that helps. Bye.